and welcome. This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the motion of lift and motion of body on inclined plane. The outcome of today's topic would be apply D'Alembert's principle to a dynamic equilibrium system by introducing the inertia force for knowing the acceleration and forces involved in the system. The topic covered would be motion of the lift, motion of body on inclined plane. The topic learning outcome would be application of D'Alembert's principle in engineering problems and know the effect of forces in the movement of the bodies. First, let us consider the movement of the lift here. A lift is a equipment which is utilized for moving or transporting the objects like maybe the persons or maybe the load from lower position to higher position, or we can take the load from higher position to the lower position. That means the lift will be moving in vertical direction from lower position to higher position, or even the higher position to the lower position. Then consider a lift which is moving with uniform acceleration and carrying some weight. Okay. Now we can consider two cases. One is the lift is moving upwards. That means from the lower position to the higher position, the lift is moving. And the second case would be the lift is moving downwards. That is from the higher position to the lower position. When we consider the lift moving in upward condition, or the lift is moving towards upwards, we can observe this is the free body diagram of the lift moving in upward direction, where this lift will be tied. This lift will be tied using a steel wire. Okay, this lift will be tied using a steel wire, and the weight of the lift along with the passengers or along with the load that would be acting in the downward direction. Okay, and as this lift is being tied using a string, there will be tension acting in the wire. Tension acting in the steel wire, and that tension is also in the upward direction, that is in the away from the object direction. So always the tension will be shown in the away from the object direction. Okay, now we are considering the movement of the lift in the upward direction. Lift is moving upwards. So how many forces are involved here? Here there are two forces that are involved. One is weight of the object and other is the tension T. So considering all the forces which are involved and taking the equations, let T be the tension or pull in the cable supporting the lift. Net accelerated force would be T minus W. Here if you consider the accelerated force, object is moving in the upward direction. Okay, object is moving in the upward direction. That means whatever weight that is being lifted or carried by the lift, it has to overcome the tension, whatever tension that is being used to pull the load, the lift which is having the passengers or the load or whatever it may be, the total load W needs to be pulled more than the weight that is acting. Then only the object will be moving in the upward direction, right? So in this case, we can say that the tension T will be higher than the weight. The tension T that is acting in the wire will be higher than the weight. So the net accelerated force would be T minus W. Net accelerated force, okay? The force which is making the lift to move, that would be considered as T minus W. So by applying the equation F is equal to ma, the accelerated force F can be written as T minus W, which can be treated as ma. Then if you simplify this T minus W is equal to ma term, you will be obtaining this equation where this tension value T can be obtained utilizing this equation W into 1 plus A by G. Right? 1 plus A by G. Here W is being converted and it has been taken common while we have taken the W term to right side. Then W into 1 plus A by G is the term utilized. Then when we consider where W as the total load carried by the lift and M is the mass carried by the lift and A is the acceleration of the lift. Now we are considering the second case where the lift is moving downwards. The lift is moving downwards. So whatever load the lift is carrying, whether it may be passengers or whether it may be load, the total load is moving downwards. So in this case, what we can consider here is the tension T will be lesser than the weight. Why? Because if the tension value is equal to W, then what happens? The lift will be stationary. It will not move up and down. If this tension is less than W, if this tension is less than W, then what happens? This object will move downwards. If this tension is greater than W, then the object will move upwards. As the force that is being applied in the upward direction is more, the lift will be moving in the upward direction. And here, as this force, that is tension, is less than the W that is being applied, the lift will be moving in the downward direction. Okay, for such case, what we will consider is, as the lift is moving downwards, weight is greater than the tension in the cable. Weight is greater than the tension in the cable. So, the net accelerated force here would be W minus T. So, previously T is larger and W is smaller. So, we have taken T minus W. Here, we are now considering the W as larger and T is smaller. So, W minus T, net accelerated force would be W minus T, which makes the lift to come downwards. So, is equal to MA. When you simplify this, you will be obtaining the value as T is equal to W into 1 minus A by G. So, there is a slight difference between the first case and second case, where T is equal to W into 1 plus A by G is the case for lift moving upwards, and T is equal to W 1 minus A by G is the case when the lift is moving downwards. Now consider the concept of the inclined plane. Concept of the inclined plane, where the object is placed on an inclined plane and it is being moved, or it is being moving because of its own weight. No forces are acting here. Only thing is, the object is placed on a smooth surface. Object is placed on a smooth surface. For such a situation, what happens is, this object, because it is inclined and there is no restrictions, that are applied onto this object. That means there is no support or no forces that are acting. So the end result would be the object will move in the down the plane direction. The object will move in the down the plane direction. So we can say that this object moves in the down the plane direction. The only force that is involved in this system is the weight W. The weight W. So this weight W, as this is a inclined plane condition, we can say that this vertical force W will be a inclined force for this inclined plane condition, isn't it? Why? Because the consideration of the axis for such type of situation would be like this: along the plane or normal to the plane. Along the plane conditions or normal to the plane conditions are the cases which we will consider for solving the problem. But here, as this is the vertical force, this vertical force would be an inclined force for the situation. So this vertical force W will be resolved into components. So that resolution is in this form. This is the vertical component and this is the horizontal component. So these two are the components of the forces that are being involved because of W. And the vertical component force, as it is beside the inclination angle, we will be getting it as W cos alpha, and this is the horizontal or along the plane component. Along the plane component will be obtained as W sin alpha. We need to consider the concepts of vertical or horizontal forces that are involved in the inclined plane condition, such that we need to take only along the plane condition and normal to the plane condition in the inclined plane problems. So, as this object is moving in this direction, then the consideration of inertia force MA. So, as the object is moving in the down the plane direction, that means the acceleration is happening in this direction. So, the representation of inertia force for this term or for this situation would be in the opposite direction to the movement of the object, or opposite direction to the acceleration of the object. So that's why we will be representing the inertia force as MA in the up the plane direction. So when you consider all these things, this would be your free body diagram of a system where the object is placed on an inclined plane. Now coming to the rough surface. If the rough surface is involved in the system, then what happens? Rough surface and it is also inclined. In this case, the surface is rough as well as it is in inclined state. So, the involvement of friction and normal reaction will be coming into picture when rough surface is being considered. So, here if you take the frictional force F, it is acting towards right side up the plane direction. We can say it is in the up the plane direction because the object is moving in down the plane direction. The frictional force will be acting in the opposite to the movement of the object. So it would be up the plane direction. Also, coming to inertia force. Always when kinetic problems are involved, we need to imply the inertia force in the system. So, as this object is achieving the acceleration in down the plane direction, what we need to do? We need to imply the inertia force in the up the plane direction, which is opposite to the direction of the acceleration of the object, right? So, in this way, we are going to implement the frictional force whenever there is a rough inclined surface that is implemented. And coming to the horizontal plane, the case will be similar for the representation of the friction as well as the inertia force. So this concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.